are you? How are you all? Are you good? Right. You doesn't sound you don't sound so good, but I'm gonna start my presentation. Okay. My name is An, and together me, An, and Hai, we together we're Team 7, and we have been developing our real-time traffic accident detection system for the past 9 months, and it has been exhausting. Okay. Alright, just kind of like what sorry. Okay, so we're going to go through with you the background, the objective, the project methodologies, the achievement, and whatever behind the scenes. So if you have any questions, say it later for our Q&A session. Thank you so much. And the first one, hello down there, you listening? Hi. Okay, so I'm sorry for too many Vietnamese up here, but let me just cite it real quick for you. So in Vietnam, we have one general situation, right? Whenever we go outside, and if there's an accident, a traffic accident to be specific, we're not gonna stop our bike vehicle and then we save them. We're not gonna do that because what we don't want the most is accountability and responsibility. What if that person have a heart attack accident? I don't know, right? So we do not want to get involved, right? And we have to wait until the appearance of the police department, right? But the police department always delay because they have many work to do, right? So what can we do to improve that with our system? Right. Sounds so confident right now. So our objective is to be using AI. It would be a shame that we don't use it because we're living in an AI era right now. So the objective of our project is to develop a efficient model, conduct research paper, but along the line we have improved and developed extra 2 websites, one for our user and one for our admins. So please stay tuned and you guys will get to see later. Okay, so for the project methodologies, I just want to put a little bit of dramatic point into this. First of all, we apply Scrum. Everybody loves Scrum? No, they don't. Okay, and we try to implement them using Horenso, which is a Japanese communication strategy, because we want to constantly work with them every single day and talk to our teammates every single time, with every day, over and over again. Okay, so that's very effective, I thought, but it wasn't, of course. So that's why we move on to the Plan, Do, Check, Act strategy, meaning because, context is because our team has a resize. For 5 people, it's only 3 people. Yeah, too bad. But anyway, we have to constantly talk to each other in order to deliver the fastest and the best possible outcome for our team. So we want not in the course of 2 weeks, not sprints, but we want in the course of hours. Like, it could be 1 hour. For example, if I had that idea, I talk to my friend, tomorrow I'm going to get that delivered immediately. So that is how we do it. Okay? That is, that might be a little bit toxic, but it helps. So, okay. So during the phase 2 and 3, we move on to the shoe hardening. I'm sorry, I'm heavily affected by the Japanese working style because I admire their work ethic so much. But in this case, I make a mistake. I only follow the shoe phase, meaning I will teach my friends all of the instruction, give them all the instruments they need in order to achieve the task. The tools, the techniques, whatever that might be. But I didn't follow through with the hard phase, meaning that I always micromanaging my friends. Hey, where's the task? Why didn't you report to me? I was very being aggressive, I'm sorry, but I love them. So I didn't go through with it. Later on in phase 3, little did I know that I should have detached myself from them. So only deadline task, and they become creative. So this is what we achieve. And I will show you how that all of this methodology works perfectly for our team. And we will be talking about the achievement that we have achieved for the past 6 months now? Yeah. Okay. So can you help me please?
Okay, so now I will mention again our achievement in that project. So we have built the model and we achieved that the MAP, that's the mean average precision of 88.9%. So this evaluation that the common metric for object detection, and it will average recall score and resistance score to resolve the overall accuracy. And also this is for the when we test the model on our own data set, and we have when we detection, so we have the detection rate of 71% and for Nalan rate at 9.52%. And also we have the research paper for academic purpose. So as I said before, so we developed two websites for the user, so the user can trial our model for knowledge sharing, and the admin to visualize ID that is the website used for the traffic management authorities. Okay, moving to the next one. So this is the architecture of our system. So it also the rest that we make the system, we collect the data, we repair the data, and then we train the model, have some optimization, and then we integrate the model into the website to take the performance. And now for the training result, I have the video for you here. You can see the example and two vertical will overlap, and it will pop up the accident, right? Okay. For the next slide, this is our methodology of training this model. So first, we have determined evaluating many object detection model, and then choose the model that's suitable for our system. Then we get data from the internet sources, then validate that result processing before we have label it by the tool called RoboFlow. Then we have the data augmentation to improve the quantity and quality of data sets. Then we got the custom data set, and then we use it to train the model, and we have validation analysis about the trained model. After that, we will benchmark that trained model to have a better result in final site and integrate the website. Okay, for this one is the process that we determine which model is suitable for our system. So we have compared some many models for the processing frame per second with the rotating video, and we still see the YOLO has the highest frame rate. So, okay, by the side where we will have the name of YOLO. The YOLO is its name is you only look once, and we use that model to build our traffic accident detection system. And also you can see that is the accuracy comparison, and it's use the data set from Microsoft with the name is Coco to take that accuracy. And we do see the YOLO is always at the high position. So you can see this is the more detail about the YOLO model with many different versions, and it will take for the Coco dataset. And this is the result of it MAP. And you can see here the latency of YOLO V8, the model we choose to develop this system, is still the highest. Okay. Now moving on in the dataset. So we have many examples of data here. That's the accident cases, accident scenario that conclude in our dataset, and also our definition of accident. So you can see we have the collision. We have the collision between two vehicles and some incident when the vehicle flip or fall, and also we have the visible deformation of vehicle. And to let the model can learn effectively to reduce the overfitting of bias, we also add some non-accident cases that we went to vertical running nearby or parallel, but not have any sign of accident. Okay, moving to this one, we have more detail about the quantity of the data set. So we have defined many lastic at the first movement we make in this data set, we separate to many accident cases, and we have too many data, then we have the overall. It has more than 2,000 images with more than 3,000 number of labels. And then we have the augmentation. We using the setting here to make the data the set more larger, and we have more cases like the environment effect, lightning, or in the dark. And then we got the inner data set with more than 6,000 images and also more than 10,000 number of labels. Right, to the next one. So this is the result when we train the model, just the result for the training model. So we use the ultralytic hyperparameter and also the ray tool. The ultralytic tuning and ray tool to find the suitable hyperparameter that can use to train a model, and it will deliver the best results. And also this is for the result MAP. You can see here for on lasses we got 74.2% accuracy for on accident and non-accident lasses. But this is just for the training data set. And when we test the data set, that means we test a model to running in some video or some image accident that the model can be seen in the training set. And then we got the result about the 88.9% for the last accident. And you can see here this example about accident when the car runs together, now a turn, or the car runs to by and vice versa, and also the bike runs together and followed by. Okay, so now I will let Nai to demonstrate more about our model result and the algorithm.
Thank you, Huy. So, as you can see before, from the testing of our model, we primarily using images to get the performance metric MAP. However, using the real accident cases, you can see that when only using the YOLO V8 model, sometimes the model will have a false detection. However, the model can still detect multiple instances of the main accident. Therefore, we implement a simple algorithm that utilize the fact that the model that the accident that occur between two vehicles can happen during multiple frames. So we can separate the slow moving false detection, and while keeping the accident detection accurate and fast. So here's a simple overall overview of our algorithm flowchart, which can be built into two parts. The first part is to gather the accident instance. In this instance, the value that will be added to a list is the tracking ID, the width and height of the bounding box, the center point of the bounding box, and the frame number that the accident happened on. Then to the next part, they check if the tracking ID has more than 2 instances or not, because we need at least 2 center points to calculate the path, and the path as demonstrated previously. And if the instant frame number is lower than the end frame threshold, and what I mean by that is, if, for example, current all of the 9 frames, the model can detect an accident, then on the current frame of number 7, and if the end frame threshold is at 5, then frame number 1 and 2 will be removed from the list, and this will go on for the next frame 8, and 1, 2, 3 is removed, so on for 9. And to our second part of the algorithm, we will calculate the accident probability using the tracking ID, the width and height of the bounding box, and the center point of the bounding box. This value are chosen to ensure the accident detection can happen consistently between different sides of the bounding box. So to test our efficient, our method efficient, and we use we use the help of the real-time accident detection in traffic surveillance using deep learning, a research paper from New Jersey Institute of Technology. And I will call this paper as NJIT study for short. This study utilizes a YOLO-based model to detect objects such as car, bikes, bus, and truck. And they using the Hungarian algorithm to track this object. And they detect accident by analyzing the trajectory of the object with the help of the Kalman filter. As you can see on the clip on the right, they can using the help of the Kalman filter, they can predict the future trajectory of the bounding box, and these video are created by using a set of parameters from the camera like height, angle, and the map on the coordinate of the Google map of this intersection to translate to a flat plane, and they analyzing the vehicle conflict from that. And within these NJIT study, they also include a set of videos that they use for benchmark, which include accident caused by car at a traffic intersection. So we compare our model, our method of detection using detection rate and false alarm rate. And you see from the example of the result, the NJIT study detect the accident by drawing a red circle around. By drawing a red circle around the two vehicles, while the method draw a rectangle bounding boxes. And from the result, you can see that the NJIT study had an overall better result. However, these benchmarks are mainly car and truck and happen during an intersection. So we want to apply our model and this NJIT study model to cases that happen usually in Vietnam or in Asia, that include car crashing into car crashing into bike, and bike crashing into bike. So with the final result, you can see that our model has a higher detection rate and better perform at false alarm rate because due to the NJIT study, NJIT study not good. NJIT study accident detection is hard to set up and so this can also prove that our model can easily detect more by accident than the NJIT study. And for the prototype, I will have Anh introduce us.
Okay, thank you. Okay, sorry. Also, so this is facilitate our project, and we also have our information down there so you can easily find us and talk to us if you don't want to. It's okay. Okay, so they can click on the demo and upload their video, but I have limited the video to be only 30 seconds, so it have higher and very faster process rates, and you only have to wait around 1, 2, 3, 4. Okay, there you go. And I want one more function that I'm adding is that you can rate our application, like for example this, and they love it, they're gonna give it 5 stars, okay? But if with that result, and they're gonna just bombard us with 1 star, oh yeah. So anyway, I'm gonna set them to send the screenshot of that particular video to me, and with the rating, so I can set, okay, that is a bad rating or good rating or not, okay? And for the methodology, for the admin website, we use design thinking. We emphasize because, well, I don't do anything wrong, okay, but I'm afraid every time I see the police officer. And I empathize with them, but particularly the administrator, right? So I define what the problem they need to. They have a lot of paperwork to do, and they're bombarded with many tasks, and also the criticism from their manager, probably, or their supervisor. And then I ideate some of the first of my design, and then I try to prototype it, and that's why I'm going to be testing it. Okay? Okay. Right. Yeah, so such a beautiful color, huh? So I try to look at what are the current system they're using. So I try to recreate the same system because I would love to provide them with the same familiarity so they get used to the system quickly if it ever got to, production. Okay, and the only thing I hate about the AI applying is that they only use AI to catch us when we do wrong behavior. For example, we run in red light or when we hit and run, they only catch us when we do that. So I don't like that. So did something to create it. Okay, sorry. Oh. This are some of the image of what content within the admin website. So now I'm just going to show you a really short clip. Very easy and short and easy to understand, so don't worry. I will walk you through every step of the way, don't worry. Okay, so first, they will lead you to the dashboard. We'll list out all the total camera. Wait, what? Okay, so all the available cameras, so in this case it's only at 8 because I don't have enough computational resources because it has been killing my GPU. And also with 160 cases of accidents have been detected throughout the past many tests that I test. Because I set the threshold limit very low, so it detects only false alarms, so no worries. And next you can just scroll down and you can see the accident by month, combined accident data, and then I will filter, okay? And filter is by month, and you can also export it by CSV. Accident by location, you click on it, so they have this location about 25. Okay, wait, too fast, a little bit too fast, sorry. Okay, so for the camera one, they can see all the list of camera, and they can click every one of them, and they can also check the live camera that or add new camera for this case, quick demo. Okay, just to stop this for a little bit. We will use in the format of M3U8, which is a very popular streaming HLS format. So nowadays, if you need to get into your CCTV feed, you're always gonna get that, or RTSP or RMTV. Anyway, you can already have any kind of that format will be easily dealt with by our system. Okay. Okay. So that is where I show you that, okay? I take gates, space, 3. You can pass the whole thing and it will fill in automatically for you, or you can just go one by one. It's okay. It's based on your preference anyway. Okay? Hold on. Thank you. And then, what do I do next? I forgot. Okay. So I want to delete a camera. I will hit delete or edit first. Okay. And then I hit delete. I said yes. Okay. And then it's deleted. Wow. Okay, so if I check the live feed, it will show you only the snapshot. And again, I do not want to waste any computational resource, so I always show the snapshot, not the whole video. And it's still, no worries, real-time notification for you, no worries. Okay, as you can see that all the accidents detected within that specific month in that specific camera, and you can see if it's false alarm or not. Okay, back, right, yes, okay. So these are the monitor where all the screen will show up, right? But again, this is a snapshot only, remember that. Okay, so every time an accident is detected, it will log into the accident log over there. This design is based on the current system, so again, with the familiarity. Okay, and yeah, pretty good. Okay, so as you can see, it's just load immediately, right? So at that time that I will record it, it's this morning actually, it's 5 a.m. in the morning. So yeah, it's load immediately as you can see. So real-time information for you, right? Move on, and you can either try to process it, then depends on the officer, they can call another officer to get to the scene, or maybe you can click on the false alarm. Okay? Thank you. Click, 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 click. Yeah, I forgot, I said on the script and I forgot, sorry. So sorry. Okay, okay. Okay, and for the records, just the same as the previous one that I just showed you. You can just filter by it, and what I love the most is to deal with my C3 trial, so I know that all the officers will love to do the same. Okay, okay. And then C3, dialog, and then show it to the user. Yes, okay. And actually in your C3 format, okay, so this is built-in function. Okay, so that are the admin, that's very easy to understand. So anyway, that's wrap up most of our presentation. Very easy to understand, I know. And now I think we're going to move to the challenge part. I think that my friend would love to talk more about it.
Okay, for the challenges when we collect the data to train our model, so we found that very time consuming when we try to collect the video feed with CCTV footage. So we have take the most of accident video from the social media like Weibo or Facebook, and then we cut into frame. But in that video, it has too many filter and effects from the user, so we need to have a reprocessing phases to remove the filter and effect, and then drop the frame into the accident visible one. And then that's the difficulty when we try to accessing the foreign sources like Peru to download from existing accident video from the other paper or the article from their study. And so now we move on to the next challenge.
Right, one of the other challenge we encounter is to reproduce the benchmark study, although we have the source code provided, but we still have to figure it out because there are little or no instruction to how to set up the environment or the needed software to run. And we have to debug the older version of OpenCV, and on this runtime, make it updated to have the correct bounding box on the object. And we and another difficult part about study reproduction is how to determine this camera preset, like camera angle and the camera coordination.
Okay, so for my challenges, because I developed the whole web app that you just saw within only 3 weeks. Yeah, trust me, it's awesome. So the most challenging part will be the streaming protocol, find the best way possible to only produce a snapshot, but also save the computational resources, and do the threading and pooling and state locking. All of them mechanisms have to work with each other. So if I have more time to design the whole structure from scratch, I would definitely try to go with a more ambitious way to be the triple D, even though everybody said, why do you have to go with microservices anyway? So I think that I will start with that because that's so many ways to prove with it. And for the streaming protocol, I'm definitely going to use streaming from NVDA. So anyhow, I think it's conclude our presentation. And these are technical skills and soft skills that we've learned throughout our 9 months. But the most important skill would be meditation, you guys. I always meditate. Okay? Thank you for listening. If you have any questions, please.
I have a question.
Oh.
You mentioned in the beginning that you are exhausted and projecting forward into your coming work life. What are you going to do not to burn yourself out?
Oh my God, sir, that's actually a very good question because I have been thinking for the past few months now. I'm working with these lovely teammates. Yeah, that have worked a lot of work to do with, okay? So after this project, probably I find a guy, settle down and get married and do my own family, that's it. Good answer?
I don't think that will happen, that you will just settle down with that. Somehow I have a feeling that will
I'll start my own company or become a stand-up comedian with stay in the basement and telling
None of those answers actually will convince me that you are going to save yourself from the burnout.
Nah, you don't know me, you don't know me. No, you don't know me, sorry. You try.
Now, how can we actually improve the system? What other attributes can we detect to make it actually more accurate?
Actually, there are two parts. So first of all will be the data first, the model first.
I think the answer I'm thinking about is much easier.
Okay, so for data set, we have try to categorize this type of accident into different classes, so we can tune the parameter for the detection method for each of the classes, and for the detection algorithm, we have a variable that called type multiplier to account for the camera stiffness, camera stiffness, and we like to create a calibration, go through a normal traffic wheel to get to create that variable value for each camera so they can detect the best.
Let me answer the question myself. I live next to a road which has a lot of accidents, right? And my accident detection rate is, I would say, 100% if I'm home. And I'm not watching the road all the time. So how do I detect the accidents?
What do you mean by?
It's a riddle.
Yeah, because this is weird. If an accident happens all the time, then yeah, you gotta move.
I have a couple of accidents every day. Yeah.
Wow. Well, so yeah,
So
so in
I'm
that
not
case.
watching the road all the time, but every time I detect it.
Gosh, I hate you, sir. You're so smart, huh? You're so
No,
smart.
I just have a good hearing. I mean, the crash is really good. Normally they make a sound. And I think the sound detection is actually a very good way of detecting the accident.
Oh my God, I swear to you, the other day I was implementing sound. I can show you the box right now.
Okay.
The box red, flooded my pie chart. But
Yeah.
I wish I could show you the.
So I think most of the cameras have that microphone as well.
Yes.
So I think the sound attribute would be very useful.
I implemented, I swear to you. But because the interval is so bad, it's beep bop all the time. It sounds crazy on my phone. I did. I did that.
That's what if the camera is close to the road, right? And the microphone has to be in the area, have the camera like a bit
mean train the model here?
And we have to account for the hyperparameter change. If the data set change, you have to change the hyperparameter as well. And
So what does it mean the model here? YOLO, what else?
Well, I think the model here we use the YOLO technique to train our model because we have some hyperparameter technique and also we have run on our custom data set. So that's in the model that we train.
What happens if you apply for the real camera? You have to customize the parameter again.
No, we just have to be customized. We customize and we use the technology so we output the model that I will train. And then the model we just iterate to the camera.
So what does it mean the model here, the AI model here? So because accident detection that's kind of like accident detection, right? But the YOLO is just work for object detection.
Yes, it's correct. But that is only correct in YOLO version 5. And now we're on YOLO version 10. No, 10 already. Yeah, this morning. They just updated on 10.
Yeah.
Yes. So there have been proving that it can track objects moving. So as Kai mentioned before, we calculate the centroid of that object and then track it forever. Like if it goes there, we're going to compare the centroid of that specific object with another centroid of the object. So we're going to track that forever. If they're going to crash, yeah, they're going to crash. If they're going to not, they're not. So anyway, anyhow, I know YOLO sound like it's a free trade, this is for baby, but no, they're not. They're strong, and the community platform is very supportive. I asked one question, he answered me within 10 minutes. And he's the founder of Ultralytic. I know he used ChatGPT, but he answered right away.
So that means you can when you customize the parameter for the YOLO model.
Customize the way it sees the object. Again, we are using the tracking of it. We're using the threading, the inference of YOLO model. Because we believe that it has so many areas to improve in the future that spans still so much. That's why we believe in it. And not other.
Why we need to change the parameter?
To
For example, when we make a comparison between young methods with the Gemini team or something like this, we say that because the data set have like the bicycle or the motorcycle. The original one, they just like have car.
so they have both car and bike. They just compare the trajectory of those objects.
Yeah.
But their bike detection is not as good as the YOLO.
Yeah. So you have to customize. So now, if you apply this system to another country, they have like different kind of the vehicle. Not bicycle anymore. Not car anymore. Maybe it's rock or something.
You know, there's one thing about YOLO is do everything. It does everything. I already gave you a documentary. So for your question, so if it's a truck, a big truck, yeah, or a tank, if you will, yeah. So if we calculate the area of the surface of it, it will cover everything. And what we do, we just need to, the centroid of it. Just like we do the KNN, neighborhood, that's it. Find the nearest, or keep on finding the centroid. Keep on finding the centroid. Okay, so this is the centroid. Okay, we have our subject, object, track it. It does, it can do the work.
But first today is your framework. I just collect the data set and put your framework and then train it again, and it can improve the detection model.
No, I'm not sure that you can. I would say that if you want to best our model right now, you gotta do a lot of work. That's all I say. I'm sorry. I'm trying to sound confident, but that's the truth, sir. My friend spent 6 months on that.
Yeah, that if you want to show that your system can outperform the other one, that's the best way to submit the paper. And if like the reviewer can accept the papers, like kind of the system is good.
how much of that data set you are using for the training and how much you are using for the testing, or you're doing some loading?
Stating is completely different from the training data set.
Yeah, but how many? So how many video for the training set? How many video for the validating set? And how many for the testing set?
Okay, for the data set, we also, this one is the overall data set, so we also have the training test, validating test and validating set and testing set. So for the document from neutrality, that we need to have the training set is much more quantity than the other one. So we set up the validating set to validate this model after training and it output the result of training. That's the about 5% of our data set. And also for the testing, we also 5% of our data set.
For the testing, we make the benchmark videos. We have 29 from the NCAT study, most of which are covered, but then are two cases of bike car hit another bike and a vehicle hit pedestrian, which we excluded from our model benchmark. So that's the 29. That's this backward. Okay, that's this result. That's the 29 video from the HAT benchmark, and this is the result from the 26 video we collected. I think that 6 of them revolving bikes, revolving motorcycle.
But how can you calculate the accuracy? So we have like 29 video.
No, this is just the detection rate. So if we will count the detected if the main accident, the instant from when they crash until they bike fall down, we count it as detected.
How can you know for now?
I mean until the
So for example, I have 100 clip, and in this clip has accident action.
we did try to use CMAT, a video annotator, but we didn't have much time, but we did have the each frame label, with accident frame label.
So how can you analyze it?
There's the next coming journal, the Science Direct, and the deadline for submission would be by September, but right now I'm just bringing that up, so I'm a little bit concerned.
I think you might have a problem with the accuracy calculation and actually proving the results, so I think consult.
Yeah. Yes, if they would spend some of his precious cash. Email.
So maybe when we problem with how can you calculate the metric?
Understood. No worries, we have 3 months more. I'm positive.
That means we wait until you finish the paper.
Forbidden in the grave.
I hate you today. I'm done.
Okay, thank you.
Thank you very much.